Hello everyone, this is Vishaka. You are watching my YouTube channel. Today I am going to present seminar on the topic wastewater treatment. Now the question arises, what is wastewater? Wastewater is water generated after the use of fresh water, raw water, drinking water or saline water in a variety of deliberate applications or processes. These are the contents of my presentation. Sugar industry, beet sugar versus cane sugar. Why do we treat wastewater of sugar industry? Sources of wastewater, typical composition of sugar industry wastewater, treatment methods, and finally, conclusion. Sugar industry. The sugar industry subsumes the production, processing, and marketing of sugar, mostly sucrose and fructose. Globally, mostly sugar is extracted from sugarcane and sugar beet. Sugar is an essential basis for soft drinks, sweetened beverages, convenience foods, fast food, candy or sweets, confectionery, baking products, and their respective industries. Do you know? Around 460 million of sugar is produced every year. The largest producer are Brazil with 72%, India with 15%, and the European Union with 10%. Beet sugar versus cane sugar. Beet sugar is derived from sugar beet, whereas cane sugar is derived from sugar cane. Sugar beet is a taproot and it has a conical white fleshy root, whereas sugar cane is a tropical tall true grass. Third point is the root of the beet comprises of 75% water, 20% sugar, 5% fiber, whereas a mature stock classically comprise 11 to 16% fiber, 12 to 16% soluble sugars, 2 to 3% non-sugars, 63 to 73% water. Next point is sugar beets accounts for 20% of sugar produced, whereas sugar cane grows entirely in the tropical and subtropical zone. Sugar beets grow entirely in the temperate zone, whereas cane accounts of 80% of sugar produced. Last point is top 5 sugar beet producers in the world are France, US, Germany, Russia, and Turkey, whereas top 5% cane sugar producers in the world are Brazil, India, China, Thailand, Pakistan, and Mexico. In this slide, you can see the diagrammatic representation of beetroot and cane sugar. In the first one is beetroot. The red, it is of red color. Dark maroon colors can be shown in the beetroot, whereas cane sugar is light green to white and yellow color involves. That is cane sugar. You can see the cane sugar in the diagram, long sticks of fiber. In the past, sugar industry only produce sugar, but nowadays sugar industries are involved in the production of sugar, electricity and ethanol. So sugar industry is now called as the cane industry. Now the question arises, why do we treat wastewater of sugar industry? Wastewater treatment is a process used to remove contaminants from wastewater and convert it into a effluent that can be returned to the water cycle. Why do we treat wastewater of sugar industry? The answer is wastewater from sugar industry, if discharged without treatment, poses pollution problem in both aquatic and terrestrial ecosystem. Also, sugar industry wastewater, when not treated completely, produces unpleasant smell when released into the environment. Sources of wastewater. Sugar industry wastewater are produced mainly by cleaning operations, washing off, milling, house floor, various divisions of boiling house like evaporators, clarifiers, vacuum pans, centrifugation, etc. generates huge volume of waste water. Periodical cleaning of heat exchangers and evaporators with NaOH and hydrochloride to remove the scales on the tube surface contributes organic and inorganic pollutant. Loading to waste water. Leakages from pumps, pipelines, centrifuging houses also contribute to waste water produced. Except this, wastewater is also produced from boiler blowdown, spray pond overflow, and from condenser cooling water, which is discharged as wastewater when it gets contaminated with cane juice. Here you can see the typical composition of sugar industry wastewater. In the tabular form, you can see the serial number 1 to 7. Parameters are given also, and you can see average values. The next column is effluent standard for discharge on inland surface water. Next one is effluent standard for discharge on land for irrigation. There are 7 parameters. First one is pH. Second one is COD, that is chemical oxygen demand. Third one is BOD, that is biological oxygen demand. TS. Next one is TDS. Next one is TSS. And last but not the least is oil and grease. These are values that is evaluated after the wastewater from the industry. Characteristics of wastewater from sugar industry. The sugar industry wastewater is characterized by its brown color, low pH, high temperature, high BOD, high COD. Order problems. Total solids and high percentage of dissolved organic and inorganic matter. Wastewater from sugar industry generally contains carbohydrates, nutrients, oil and grease, chlorides, sulfates and heavy metals. BOD, that means biological oxygen demand. COD, that is chemical oxygen demand. Treatment methods. Treatment of sugar industry wastewater requires a process that combines mechanical, chemical, and biological treatment measures, screening, grit removal, flow equalization, sedimentation, or dissolved air flotation are used to reduce suspended solids, that is SS, load from sugar industry wastewater. Biological treatment methods are applied for the reduction of soluble organic matter. Disinfections. Biological treatment includes aerobic and anaerobic process, except biological methods. Physicochemical methods are also used for sugar industry waste water treatment. Biological methods. Since sugar industry waste water contains mostly sugars and volatile fatty acids which are easily biodegradable. Therefore, all the biological, that is anaerobic and aerobic treatment process are suitable. Aerobic treatment. Aerobic biological treatment generally involves degradation of organic in the occurrence of oxygen, that is O2. Conventional aerobic treatment includes activated sludge trickling filters. You can see the trickling filter in the corner of the slide. Aerated lagoons. Combination of all. Earlier, lagoons were used for sugar industry waste water treatment because of being an economic process. However, larger area requirements and emission of unpleasant and annoying smell during the treatment process are some of the disadvantages of lagoons. Aerated lagoons were also used in the past and showed lesser residence time and area required compared to lagoons to treat sugar industry wastewater, but oxygen consumption and HRT, that is hydraulic rotation time, were found to be high, and still large area requirement is disadvantage. Anaerobic treatment. Anaerobic treatment method for concentrated wastewater in terms of pollutants, that is, as the sugar industry wastewater is widely used method in the industries. It has several advantages over aerobic processes, which include the lesser energy required, methane production due to the degradation of organic matters, which is a source of energy, and lesser sludge production, which indirectly reduces sludge disposal cost greatly. Sugar industry wastewaters are biodegradable except oil and grease, which are not easily degraded by anaerobic process because oils produce long chain fatty acids during the hydrolysis step, which causes retardation in methane production. Long chain fatty acids were reported to be inhibitory to methanogenic bacteria. Reactors generally used for anaerobic treatment of sugar industry wastewaters are as follows. First, anaerobic batch reactor. Second, anaerobic fixed bed reactor, that is AFR. Third one is upflow anaerobic fixed bed reactors, that is UAFB. Fourth one is upflow anaerobic sludge blanket, that is UASB reactors. Physicochemical methods. First, coagulation with inorganic coagulants and adsorption are widely used for the removal of suspended, colloidal, and dissolved solids from waste waters. Generally, coagulation is used in the primary purification of industrial wastewater. Second, in coagulation process, insoluble particles and are dissolved organic materials collect to be larger and are removed by sedimentation or filtration stages. Electrochemical treatment. Electrochemical treatment process is an emerging wastewater treatment technology. Electrochemical treatment method involves first electrooxidation, second electrocoagulation, third electroflotation. Conclusion: industrialists should check their equipments or instruments to avoid leakage. Each industry should follow environmental policies, regulations, and environmental protection acts to conserve the environment. Industrialists should use such as raw materials which will give maximum good products and less toxic waste in fewer quantities. Industries should use installed in low-lying areas away from the public locality. Each industry should have ETP, that is effluent treatment plant, to treat the effluents which can be further used for the agricultural purpose. Thank you for being here today. I really appreciate that you took time to be here and listen to my presentation. Thank you, everyone, for being a wonderful audience, and you shown your interest and shown patience for my presentation. Thank you so much.